Hi, welcome to the topic on implementation of k-means. By the end of this video, you will be able to perform basic pre-processing of data before building the clustering model. So far, we have been discussing the theory of the k-means algorithm. Now, we will shift our focus towards the implementation of the k-means algorithm. But before we do that, let's briefly discuss the problem statement that we will be handling during the implementation of the k-means. A marketing firm wants to launch a promotional campaign in different regions of the country. So, in order to do that, the firm needs to understand the diversity in the population demography so that it can plan the promotional campaigns accordingly. We are provided with the population data based on different regions along with the demographic. The objective is to segregate the regions into different groups so that the marketing team can plan their resources accordingly. So we have to apply clustering techniques in order to segregate the regions into different clusters, which will help the marketing team. You can find the link to this dataset in the helper text below. The name of the dataset is population_data.csv. Now, let's begin by importing the data using pandas. On using the data.info function, we can see that most of the features available are of object data type. Also note that there are only 38 entries in the dataset. Therefore, we would not be needing much computational resources as maximum possible clusters are 38. So let's use data.head function and see a few rows of the dataset. Here we can see that all the features except region and office location ID are numerical in nature. Then why is Python recognizing them as object data type? This is because the features contain values separated by commas. As a result, they are not numerical in nature. Since sklearn only deals with the numerical data type, we will have to manually convert these features into numeric data type by removing the commas. For that, we will define a list numeric. This list will contain all the features in which we will operate upon. Next, we will define a function called cleaner, which accepts an element and removes the comma from that element and returns it. In the next cell, we will simply use the .apply function to every feature present in the list numeric with help of a loop. After using the data.head function, we will observe the resultant outcome. We can now see that all the numeric values do not contain any commas in them. So let's again check the data type of the features. Although we have removed the comma from the values, the data type is still in the object format. Therefore, we will convert them to the numeric type explicitly. For that, we will again modify the columns present in the list numeric. We will use the pandas.to numeric function with the help of data.apply function. This will convert all the features in the numeric list to numeric data type. Let's again check the data type of the features. On running this cell, we can see that all the variables are of numeric data type. Next step is to do feature scaling. But before we move forward to that, we will verify the integrity of the data. Now you might be wondering, what do we mean by integrity of the data? If you noticed, we have columns for the population corresponding to Indians and foreigners and also the total population. A simple integrity check would be to make sure that the grand sum of Indian and foreigner populations adds up to the total population. For this, we will add up all the values in the column Indians and foreigners and then again add the two columns. This should be equal to the sum of the total population column. So when we add and subtract the two values, we get 0 as the output, which means that Indians and foreigners add up to the total population. Let's also check whether these four columns based on the male and female gender add up to the total population. On doing the same operation as before, we find out that the output is a negative value. What does this mean? The total population is greater in value than all the males and females, which means there are people in the population who do not identify themselves as male or female. This is an important piece of information as it can produce new knowledge in our modeling process. So let's create a new feature called Other. This column will consist of the population who do not identify themselves as male or female. Note that we are defining column other based on the population of the whole region. You can also define the columns Indian others and foreign others, but we let you figure out on how to perform that. Now for defining a new column, we will simply add up male and female under each category, that is Indians and foreigners. Note that we are sorting this as MF sum. Now we simply subtract the MF sum from the total population. The resultant will be the number of other who do not identify themselves as male or female. Note that we could have used the data.apply here, but since the dataset is small, we used this method. We will again use the data.head function and check the first few rows. On running this cell, we can see that another column, that is other, has been added at the end. Note that this information can be useful depending on the type of campaign the organization wants to run. Now, let's have a look over the two features, region and office location ID. On printing the number of unique values that they contain, we can see they both contain 38 values, which is equal to the number of observations in the data. As a result, these two features simply contain the region and office codes which do not contribute any information. As a result, we will not be considering these two features while clustering. Now you might be wondering why. This is because all the values in these columns are unique with respect to the region, and hence there is no similarity between any two region codes or location ID. We will also drop the total population from the data. This is because total population is already explained as the sum of Indians and foreigners. Moreover, these other features contain more granular information as compared to the total population. As a result, we will not keep these three mentioned features while we perform the clustering technique. So, we will drop the three columns and store the remaining data in a new variable called data1. Next, we will check the first few rows of the data again. As we can see, all the three variables have been removed. Now, the last step before clustering is to normalize all the variables, so all of them are of unit scale. For this, we will import the normalizer from the sklearn.preprocessing module. Then we will create an instance of the normalizer and call it a norm. Note that we are saving the column names before normalizing. We will use it later in this cell. Next, we will use this instance to fit and transform the data at the same time. Lastly, we are again organizing the data in the form of data frame and using the .head function to look at the transformed data. Here, we can see the normalized values of each feature. Now in this video, we have done all the basic pre-processing. In the next video, we will move on to the clustering phase.